Hello and welcome to the class. Let us first revise what we have learned so far. We have learned about basic Android programming. We learned about fundamentals of Android applications, how to use Android Studio to create Android applications, and then we learned one of the basic component of Android applications, that is activities. We learned about activity lifecycle, and we learned about that what happens to an activity lifecycle when we interact with a user device, such as by pressing back button or by pressing home button. Then recently we also learned how to create more than one activity in a single Android application, and then how to use intents to communicate between different activities. Today we are going to learn something different but very useful. It is called observer pattern. You may have heard about design patterns earlier. Design patterns are recommended practice of programming which have evolved after lot many years discussions, arguments between the developer community. The patterns have been proposed as the necessary as well as recommended practice of programming. So today we are going to learn observer pattern, which is very closely related to MVC that we use in our Android applications. So let us start with what is observer pattern and how does it relate with MVC or even with the publish subscribe. So the observer pattern is based on a simple premise that one should not miss out when something interesting happens. Now what that interesting thing could be, for example, if you are subscribing to, let us say, a news item or a newspaper, you would not like to miss out when a new news is published. Or if you are subscribing to a weather station, you will not like to miss out if a weather update has been done. The observer pattern in Java enables that. Let us understand with a simple example. Let us say that we have a weather monitoring application. This application has three components. The one component is the actual weather station, where the different values related to weather are updated. For example, there may be a humidity sensor device which updates the humidity value. There may be a temperature sensor device which updates the temperature value. And there may be a pressure sensor device which updates the pressure value. Now all these weather station data is pulled by a weather data object. And then this data object tries to display this data on a number of devices. Some of these devices could be mobile phones, and some of these devices could be web browsers. Some of these devices could even be smartwatches. Now you can see that this is very similar to what we see in the MVC. Let us go further in our example. Suppose we want to implement it. So how do we implement such that whenever the weather station updates any data, the view is updated on all the display devices? That is our task. So our weather data object knows how to talk to the physical weather station to get updated data. And our weather data object then updates its displays for the three different display elements that we are currently considering. So in this example, we will be considering only three display elements. One is a simple display element that presents current condition, that is current values. Another provides statistics by giving average, min and max of the values. And the third one provides a weather forecast. These displays could be running on three different type of devices, or a single device, or multiple types of devices having different combinations. Now let us see that what we will have in our weather data class. So our weather data class will be very simple. It will try to get the actual sensor values, and then it will have a method which will be called when any of these measurements change. Now we will have to see that how do we implement this measurement change method, and how do we implement it for the three displays which will be displaying the new measurements. Number one thing that we have to keep in mind is that the displays are always updated whenever there is a new measurement. and the system must be expandable so that one can add a new display if it is needed. So here is a possible implementation of measurement change. It first tries to get the temperature, humidity and pressure readings, and then it updates each of the display one by one. Now let us see how does the observer pattern fits here, or how does the observer pattern fits in real life. Let us take a very simple example that you encounter in your daily life. Many of you may be reading newspapers. Some of you may be reading one newspaper, some of you may be reading more than one newspaper. Now, what do you do when you want to receive a newspaper? You simply call a newspaper person and you ask that whether that person should deliver a Times of India or a Hindustan Times or a Amar Ujala newspaper to you. Your neighbor may be asking for a different newspaper, and your another neighbor may be asking for more than one newspaper. So, which means that you may subscribe to any number of the newspaper, and as long as you remain a subscriber, you will get these newspapers. And one day you may decide that you do not want to receive any newspaper, or maybe you don't want to receive the Times of India anymore. That day you unsubscribe from either one or all of the newspaper, and then subsequently you stop receiving the newspaper updates. Now, just because you subscribe or unsubscribe from a newspaper should not affect your neighbor's subscription or unsubscription, and similarly your neighbor's subscription etc. should not affect you. Let us try to understand it from this simple diagram. Here you can see that this is your subject which is of interest, and these are different observer objects. These observer objects have subscribed themselves with the subject to receive updates when the subject's data changes. So whenever there is an interesting change in the data of the subject, these values are notified to the observer objects. And if there is an object which is not an observer, that object does not get the notification. Now here with one subject there could be multiple observers. Similarly, a single observer may subscribe to different subjects. Now let us see how it all gets implemented in Java. We are currently assuming that Java is not providing us any facility to implement observer pattern, and we have to write everything from scratch. Later on we will also see examples of Java classes which implement observer patterns. So what we need to do is we need to declare a subject interface, and the object that use this interface to register as observers and also to remove themselves from being observers. So there is a subject interface. The observers who want to observe this subject will have to register as observers or remove themselves as observers. For the subject, it must have something like notify observers so that it can notify all the observers. Now all the potential observers need to implement the observer interface. The observer interface has only one method, let's say update, which gets called whenever the subject's state gets changed. For a concrete implementation, the concrete subject will implement the subject interface, and that is it will implement the register observer, remove observers and notify observer methods. And it will also have something like get state or set state, and when there is a change in the state, it needs to call the notify methods. The concrete observer needs to implement the observer interface, and it needs to only implement one method, that is the update, which is run when the state of the subject is changed. Here are few important things. The subjects and the observers are loosely coupled, which means that they only know, the subject knows only thing about observer, that it implements a certain interface, and it need not to know anything more about the observer. Also, we can remove and add observers at any time without changing anything in the subject. So this allows us a reuse of subject and observers, and the change to either of them will not affect or should not affect the other, as long as they implement the interfaces that you have defined. Now let's go back to our weather application. So our weather data was one object that had many states: temperature, humidity, pressure that change. And this was the state in which our observers were interested. So our displays for the observers, which were many and of different types. So only thing our observers needed to implement was the update method. So that is how we can possibly design our weather station. So our interface for the subject should have methods such as register observer, remove observer, and notify observers, while our interface for observer should have only method called update. So all our weather component implement the observer interface. This gives the subject a common interface to talk to when it comes time to update the observers. And then we can have a simple interface to make it more modular program called display element, which has a display interface. And because each observer will be doing a different type of display, they will implement this method as per their need. Now, for our weather data, we only need the three methods that we defined earlier, and then some methods which takes account of the state of the weather. So something like get temperature, get humidity, and get sensors. And then the measurements changed is called whenever there is a change in any of these variables. Fine. Now, the display element shows the current measurements from the weather data objects. The display elements, we have defined three types: statistics, current conditions, and the forecast display. All the display elements display a different type of value. And then there could be another third party displays which implement the same method and may display a different value depending on the weather data. If we look overall, then we have few interfaces, namely three interfaces. Out of them, two interfaces are subject and observer, which we described earlier, and one is an optional interface called display element because it is giving just a way to display the data. All our displays, that is all our observers, need to implement the interface observer as well as the interface display element, while our subject weather data only need to implement our interface subject. Now Java does provide an observer pattern by default. So in Java, whatever we were saying for the subject is called observable, and whatever we were calling as observer is called observer only. Observable class takes care of all the methods that we need, that is add observer, delete observer, notify observers, and set change, while the observer interface has the same update method that we had earlier. Now let us look into a program and try to understand it. I have created a simple program based on our example that we were discussing. So in this program, first part of the program is made without using the Java classes for observer pattern, and then the program is remade by using the Java classes for observer pattern. So first let us see the program where we do not use any Java specific class for observer pattern. So this is our first example. Let us first look into our interfaces. So our subject interface has three methods: register observer, remove observer, and notify observers. Our observer interface has only one method, which is update, takes the value of temperature, humidity, and pressures. And then our display element interface has only one method called display. Now let us look into the concrete implementation of our subject that is provided in the WeatherData class. So let us see how are we implementing, for example, register observer. If we want to have a functionality in which we can add or remove observer depending on how they come and go, we need to choose a data structure which permits this. One such data structure is array list. Array list can be extended. Unlike array, which cannot be extended, that's why we are using array list. So we use an array list, and whenever a new observer wants to view the state of our subject or gets interested in the state of our subject, we add that as an observer. So observers are added using the register observer method, which means that they are added into the array list. Similarly, when an observer leaves, remove observer method is called with the index, and that is removed from the observers array list. Now the notify observers does nothing more except going through the observers list and then calling the update method of each of the observers. And whenever measurements change, that is whenever there is a change in the temperature or humidity or pressure, notify observer method is called, which in turn calls the update method of all the observers. Then in order to take into account the state of the object, we have the method called set measurements, where the new value of temperature, humidity and pressure are set. Now let us look into the implementation of an observer, a concrete implementation. For this I will choose what I will say current conditions display. Current conditions display is an observer, so it implements the observer interface, and because it needs to display its value, it also interfaces the display element. So there are the values temperature, humidity and maybe pressure as well. So current condition display does not do anything, it gets initialized, it registers itself with the weather data. So if you remember, this was our subject and weather data was our concrete implementation of the subject. So what current conditions display is doing, that it is registering itself to the weather data using the register observer method of the weather data. So here the current condition display is called with the weather data in the constructor, and then it sets the weather data to itself and then register to its own weather data subject variable, and then it register itself as one of the observer of the weather data. This act will add this display into the array list of the weather data. Now what happens whenever the update method of this display is called? Whenever the update is called, it changes the value of its temperature and humidity and it displays them. The display is coming from the display element interface and does nothing but only does a system.out.println in our case. Similarly, other observers have been implemented. For example, forecast display again takes the weather data object, registers itself and updates, though its display is different than the display of current conditions. And same thing is for the heat index, which registers itself similar way, updates itself in a almost similar way, but its display is very much different than the other two displays because it tries to complete a heat index using a mathematical formula. And then we have another display, another observer, which is statistics display, which does nothing except adding itself, and then it tries to calculate min, max, average and displays those values. So this is the concrete implementation of our subject and observers. I will just quickly repeat. The subject need to have a data structure in which it can store the observers. The observers take the subject object as part of their constructor and register themselves as the observers. implement the update method, and hopefully they are registered as the observers. Now let us check this program. So here is a class that checks it. It creates a weather data, that is a subject, and it creates three objects, three observers of that subject. So current condition display, statistics display, and forecast displays are three observers of the same subject. And then one by one, I am changing the measurements. Let us run this program and check the output. So we will go to weather station, we will right click and we will say run weather station. Let us come down. So when the first set measurements is called, let us see what is the workflow. The set measurements will come here and will in turn call measurements changed. The measurements changed will then in turn call notify observers. The notify observers will then call the update method of each of the observers. That's where the update method is defined. So now let's go back and see the output. So for the current conditions, for example, the update method calls the display and display only prints out this statement, and we can see this statement here in the output. Current condition 80.0 degrees and 65% humidity. Similar things will happen with respect to the display of statistics and forecast. So if you check, the statistic display is nothing but prints average max min, as you can see average max min, and then the forecast display also does nothing else except display the forecast and a good tagline. So for example, improving weather on the way. That is what is published. Now when the measurements got changed in real life, these measurements will be changed because the sensor that was sensing the values registered a new value. So whenever the measurements got changed, all the displays will be updated, and as you can see, the new three lines shows the new update. You see now the forecast has changed, and then when again the measurements changed, then again the displays are updated. So you saw that how easy it was to implement the observer pattern with nothing more than the standard Java classes. Now let us look again into what Java provides to us and how we can use the observable and the observer of the Java and implement the observer pattern. So we will be using the same example. So let me go and show you. So the second implementation uses the Java classes. So here our weather data is same, but it now extends observable, and the observable is one of the Java class which I have imported. If I go into the code of observable by pressing Ctrl on my keyboard and then pressing click, I can see how observable is implemented in Java. That is the another beauty of Java programming language, that all the code is available for you to see. And you see that observable is implemented pretty much the same way that we implemented our own subject. There are some add observer methods, there would be a delete observer method, and there is a notify observer method. We were using an array list, they are using a vector. Let's come back. So now you need not to implement the array list or manage it. Java is doing it for you. All you need to do is to have the measurement changed and the set measurement method. In our earlier weather data, we were also implementing register and remove. Now we need not to do that. Only thing we need to do is measurement changed. Now let us see what is the difference in the observer. So let's pick the current conditions display observer, which is the same as what we picked earlier. Now this is implementing an observer, and here is the observer that it is implementing. Let me click it. So this observer is also an interface defined by Java, and it also has only one method called update, which takes the observable as one of the parameter and object as another argument. So let's go back and see, just like the last program, this one also takes our subject as a part of the constructor, adds itself to that subject, and then calls the update. So whatever we were doing earlier ourselves, Java is doing it now for us using the observer and observable. Let me also run this program and hopefully I will get a similar output. So this is exactly same. Let me run it by right click and then I do this, and as you see that every time, just like the last program, I am again getting all the three outputs being displayed. So these are two very simple programs showing you how you can use observer pattern in a Java program when you need to define multiple observers for a single subject which has some interesting states. Why I discussed observer pattern is based on that we are using and developing Android applications which use this MVC architecture pattern, and MVC is very related to observer pattern, as you can now guess. We have discussed MVC earlier before we started improving our math quiz applications, but here is a quick repetition. In MVC also, there is a model, a view, a controller. While the view is responsible for displaying data, model is responsible for managing data, and controller is for the application logic. You can see the relation between subject and observers here. If something changes in the model, the view is updated. This is all for today's class. It was a little bit different and away from the Android programming, but understanding some of these patterns is very important to understand and to learn how to develop good Android applications. Thank you.